So first of all, let's look at first of all before starting with the Hadoop, right? The word Hadoop is very common these days, and you might have heard it at many places. But before starting on to Hadoop, let's look into how our normal course flows in our course schedule with Edureka. So we have live online classes. So when we say live online classes, it means you will be interacting directly with your instructor. So it will not be any kind of a recorded session or something, or video will be played out to you, right? So okay, I can see few people are saying unable to hear. Ram, is it fine now? I think you might be having some issue at your end. Am I audible and clear, guys? Okay, great. I was just checking because I think it might be a problem isolated to few of the participants. Okay, so how the course flows. So most important thing is live online classes. Here you will have an interaction with the instructor directly. So you can post your questions. So while the classes are going on, you do not need to take down any notes, right? So you can concentrate on the concepts, or clear your doubts, because we record all the classes simultaneously. So the classes, they will be uploaded to our LMS so that anybody can download it and watch it in their free time. So they can refer them, see what's the command executed in the class, or let's say what were the config files used in the class, or how the particular setup was done, right? So you don't need to take down notes for anything. So everything will be in LMS, the recorded sessions. The third part will be you will get a 24/7 support. So we have a support team with us, the Edureka support team, so which has kind of a distribution list which is monitored 24/7. So if you have any queries means it might be logistic issues, it might be issues related to any of your course contents, you might be facing issue setting up, let's say, a cluster, or you might be finding it difficult to grasp a concept. So you are most free to reach out to the support team. So they will be able to help you out or direct you to the right resources. Another thing which we follow in our course modules are, we go with our module-wise quizzes. So what does it mean when we say module-wise quizzes? So we have different industry standards, right, for exams. For example, like Cloudera is there, Hortonworks is there, right, and MapR is there. But let's say the most common one is Cloudera. It's easily available even in, let's say, the EMEA region, Asia Pac region. So we, in between the courses or in between the module flow, we have quizzes, so which kind of gives you a glimpse into what kind of objective questions can be asked, because the exams like the Cloudera is mostly an online exam which has multiple choices, right? So it will be similar to that. At the end of the course, you will be assigned a project to work on and submit your report. So the best thing about Edureka course is it's not just theory, right? It's not like you will be given a set of, let's say, 20 or 30 questions and you have to select the right options. So it will be testing you whatever you have learned over a period of course. So you will be asked to, let's say, set up a cluster with these specifications, and you have to take care of, let's say, addressing 4 terabytes of data. So you have to submit your config files with the reports, so that we know that you have actually set up your cluster, you have actually run the tests, you have actually arrived at the use case, right? Accordingly, your grading and all that will be done. So at the end of the course, you will be issued a verifiable certificate. So This certificate has a lot of credentials because it is based on your true hands-on knowledge rather than just a theoretical knowledge which you might have, let's say, grasped by reading a blog, right? So it's not like that. So let's look at what actually is the main objective of this session or this webinar. So at the end of this session, you should be able to understand how Hadoop overruled the limitations of traditional technologies. So it's not that distribution computing is new. Distribution computing has been there. Distributed computing is there for a long time. And even before distributed computing, we had a concept of called parallel computing, right? If somebody is from the parallel computing world, they might have heard about MPI stacks and all. So we already had that. But we will see how this is solving the problems we have at our hand in the present day scenario. We will also look at what are the key responsibilities of Hadoop administrator, right? So in a day-to-day role, what he does, right? What are the typical tasks and what are the, let's say, skill set which are needed for a Hadoop administrator. We will also look at some of the advanced concept which has been introduced into Hadoop in the new version, which is Hadoop federation and high availability. We will also understand the Hadoop cluster modes, right? We can run Hadoop cluster in varying modes, right? Depending upon the size of data we have. It can be a single node, it can be 10 nodes, it can be 1,000 of nodes, right? So we will look at what cases we can have. Then I will do a quick demo on Hadoop cluster setup, and also we will look at some very basic things like how you commission or decommission a node, or maybe let's say a rack awareness, depending upon how much time we have. So considering the time constraint we have in the webinar, it might not be possible for us to, let's say, do a deep dive into a cluster setup, but I will walk through you, let's say, important config files, setting up a name node, setting up a data node, let's say even a secondary, how rack awareness works, and we will look at some commissioning and decommissioning of data nodes. Okay, so let's get started. So first of all, before going on or directly moving on to the Hadoop world, first we should understand why Hadoop is needed, right? To understand that, we should understand what is big data, right? So big data is a very commonly used word nowadays. You hear this quite often, everybody talking about big data. So the very first thing which comes to our mind when somebody says big data, it means lots of data, right? The word big, they relate to lots, the size of data, right? We talk of data in terms of terabytes and petabytes. So big data is a term basically for the collection of large data sets, which are, in addition to being large, they are also complex, right? So that our traditional systems, they cannot manage them. For example, the databases, for example, let's take an example of MySQL and Oracle database. They have been doing very well over the years, right? But they have a limitation. What limitation? In terms of size. So when you go beyond certain size, you have to manually partition. So if somebody is a DBA in the audience, they will understand how difficult it is to shard and partition a database, and you have to take care of relationships manually. So to address all these complexities, we need a platform which can do things automatically for us. So currently the challenge which we have our hand when we talk about large data set is how we will capture that data, right? Where we will store that data. It is not possible for us to, let's say, store 1 petabyte of data in just one system, right? It's not about putting more and more drives or more and more hard drives into a system. There's lot of things which we have to consider, because every system has some limitation in terms of, let's say, the CPU, in terms of how much IO throughput we can have, in terms of, let's say, a network throughput we can have, right? So there are a lot of things, right? So it's not just about adding resources to one box. So we have to address the challenge of how we will capture it, how we will make sense out of that data, right? So when we say sense out of that data means how we will store it for a certain time, how we can search it, how easily we can extract data if need be, and how easily we can analyze, let's say how easily or quickly we can build a report on it and give it in a nice format, right? So end of the day, the technology is always there to help the business, right? Technology in itself does not make sense, right? End of the day, it has to go hand in hand with any of your business. So when we talk about the business, you need to project your data which could be easily understood by non-technical people, right? Let's say it might be a CEO of a company, or it might be some of the board members of your company, right? So it also depends how easily you can visualize data, right? In the form of graphs, or it might be histograms, right? All those things. So the challenge is we need systems which can handle this, right? So we need a platform which can address this. So another challenge we have nowadays is we have so many machines hooked onto the internet. Just take a simple use case. A single user, he might have a desktop at home. He might be having a handheld device, let's say a mobile, or another, let's say an iPad, or another devices, right? So the same user is hooked onto internet from many devices, from multiple devices. So look at the size of data, the frequency of data which is being generated by even a single user, right? So a user might be logged into, let's say, a simple Facebook app from all these devices at the same time, right? So how you link all these connections, how you, let's say, track the cookies, how you track the user login behavior, right? A lot of things comes into picture. And also nowadays you don't have to sit in front of a system because you have large server farms. Let's say you might be running a front-end server farm of 2500 servers, which is just serving your front-end traffic. Let's say www.yahoo.com, right? So it's not that there's an engineer who will be sitting and doing commands one by one, or doing an extraction of logs or anything. So you have automated systems in place. You will have scripts in place which will automatically capture your events and redirect it to another central system where, let's say, all the logging will happen, a log collection will happen, right? So the size of data will grow exponentially because now it is not one system, but you will have thousands of systems, and automatically they are generating logs. You can be very verbose, right? You might be, let's say, generating log for each and every event. So the size of data can quickly go into terabytes and petabytes of data. So it's not just about the simple logs, right? So end of the day, let's say you have to run your marketing campaigns, right? Ad targeting, advertising, all those things need to be addressed. So there should be a system which can quickly make a decision that what ad should be shown to one particular user, right? So we need something which can work on these large data set. So as I was saying, big data, right? So very first thing which comes to our mind when we say big data is the size of data. But this is not just about the size of data. So there is a very good definition from IBM where we call 3 V's of big data. Now some people also has introduced 2 more. They called 5 V's, but this is the original definition, and this is the most important points when we define or talk about big data. So the 3 V's are volume, velocity, and variety of data. So what does it mean? Volume means the size of data, right? Where we talk about in terms of petabyte, terabyte, exabyte, right? Large amount of data. Velocity, we talk about the different use cases. Velocity mean it can be in different sense. For example, let's say I might have a use case where I am getting data 1 terabyte in a day, right? Let's say at 6 p.m. in the evening, there's a data stream which comes, write 1 terabyte of data for me. Another use case could be every 1 hour I am getting 1 gig of data. Another use case could be every minute I am getting 100 MB of data, right? So end of the day, I might be getting the same amount of data, but the frequency, right, the velocity, how that data is generated might vary, right? So different use cases we might have. Another is the variety of data. You might have simple text files, you may have web server logs, you may have videos, or you may have audio files, right? How you can use a common platform to take care of so many use cases and variety of data. So it should not be that you will say, okay, I will have one platform for text, another platform for video, and some another platform for images, right? It will be very costly and very difficult to interlink the systems if that will be the case. So we need a platform which can address all these things, right? So now why we cannot use, let's say all these things have been there for a long time. Let's say we have been using Oracle or MySQL for addressing many of these issues for a very long time. But what challenge it poses? For example, let's say I'm using Oracle or the traditional ETL model, right, where I extract, transform and load data, and I have a warehouse where most of my data is archived, means it is sitting there dead. The only live data is the data which is sitting directly into my DB, let's say a MySQL or an Oracle DB. So whenever I need something, I go to warehouse, pull that data onto my Oracle DB and run queries on that, right? So I have a limitation. So most of your data is archived. So let's say you have, in the slide, let's say we have a case where you have, let's say 2 petabytes of data. So you will not be storing 2 petabytes of data in a directly into a DB, let's say a MySQL or an Oracle DB, because it will hit your performance in terms of indexing, how quickly you can do search and all. So what you do, mostly you will put that into a warehouse and you will think, okay, I might not need this data in the near future, so let's archive it. If needed, I will pull it back. So what will be the disadvantage of this kind of approach in the current day scenario? The disadvantage will be you have so much competition, right? Everybody is into social media. Everybody is into advertising on social media. So who wins? Whoever can better target their audience, right? Customers. So it should not be that one company, let's say you might have different companies who are selling a shoe. Let's say you have a Reebok, you have a Nike, right? They are all, let's say, doing advertising for selling their products. Both have the same kind of products. Both have good quality products. But let's say one is targeting 1,000 users, other is targeting 1 million users. So the one who is targeting more users, they will have a higher sale ratio for targets. Why? Because they are able to reach more audience. So how they are able to reach more audience? If they are able to do analysis on a larger data set. So what does it mean? Instead of archiving my data and making my data sit into and some warehouse and being dead, what I can do, why not keep the entire data live, right? Why not keep the entire petabyte or terabyte of data live so that I can work on the entire data set, right? So instead of having one single node, why not build something distributed which has thousands of nodes, which can store petabyte of data, and entire data is live. So when need be, I can not only do trending or analysis on only data of one day. I can do analysis on data of, let's say, last whole 1 year. So I can see how the market has responded over the last 1 year, and I can better position my product accordingly, right? So it is helping the businesses in better understanding their customers. So nowadays, the big data analytics is not only restricted to, let's say, a computing domain. It is found everywhere, where it is, whether it is, let's say, stock exchange, whether it is weather forecasting, whether it is sensor data, whether it is, let's say, a SETI project, or whether it's a Hadron Collider, right? So the use cases are very vast. So we cannot classify and say that it is restricted to only one kind of a use case. So now the question comes, now we have understood what data is, the size of data, and how that data is coming, right? Data might be coming from some sensors, it might be coming from some satellite data, it might be a Hadron Collider data, it might be all the sensors in a flight, right, which are taking care of, let's say, load carrying capacity, the fuel a plane can carry, the number of passengers it can take in one time, right? So they can better calculate their round trip times to save on fuel consumption, for example, right? So all those factors. So all this data you have now, right? So you need a platform to solve all these challenges which are posed. So you have a platform which is called Hadoop. So Hadoop platform is designed to solve problems posed by big data. So you have to take care of size of data and different use cases of data and different varieties of data, right? So you need a platform. So when you say Hadoop, first of all, Hadoop is not a tool, right? So some people think that, okay, Hadoop is something, okay, I will go to internet, download Hadoop, and it will provide me everything. No, it is not like that. So Hadoop is actually a framework that allows for distributed processing of large data set across a cluster of commodity hardware or commodity nodes. So this is what has been the main point for Hadoop, commodity hardware. If you look at parallel computing, right, you need a dedicated hardware, you need dedicated channels. So if you might have got a chance to see that, you will have that serial cables which will be running either from the serial COM1 ports or parallel ports, right, connecting the systems together. So you need a dedicated hardware for running parallel computing, which costs a lot of money for any organization. Let's say if you are going for mainframe computers or high-end enterprise systems, let's say Dome servers, GS1280 and all, they will cost you a lot of money. So what Hadoop has done is, it has reduced the cost. Why? You can plug in your non-enterprise class servers, right? So when we say commodity servers, it does not mean desktops, right? It does not mean the desktop which you run at home you will plug into a Hadoop cluster, but it means you do not need to go for enterprise class servers. You do not need that big blade servers and all, right? Costly blade servers. So you can scale them easily. So the important thing here is, it is a framework. It is an open source data management model. It is purely open source, right? There's no proprietary thing. You can go to Apache, right? This is a project under Apache. Download it, play around with it, modify it in the way you like. And it is a scale out system. Scale out means it is designed for horizontal scaling. So you understand in a production, right? If you go into infrastructure side and if you're talking about scalability and capacity planning, you might have faced the challenges that it is very difficult to scale a system vertically, right? Because there is always a limit how powerful a node can be, right? I cannot keep on adding memory or keep on adding hard drive or let's say the CPU to a system, because there are a lot of limitations. Let's say in terms of a socket I can have the memory DIMM slots I can have, right, or the throughput which I can get through one system. So it is always better to go for horizontal scaling. Horizontal scaling means you add one more system, right? If need be, you add one more system. So it is easy to scale out and the cost is also reduced. So you can just take a, let's say a P4 system with 4 gig memory, just plug into your existing system. So it scales out. So this is the core of your Hadoop design. So the key characteristics when the Hadoop was designed in the early phases, right, so it has gone through a lot of development, right? It is not that everything has happened in one day. It has gone through a lot of improvements. But the core characteristics when Hadoop was perceived was it should be reliable, right? Because here we are trying to address big data problems. So it should not be that I put my data on my Hadoop cluster, but data is gone, or I have loss of data, or data gets corrupted. So first thing is it should be reliable. Then only companies will invest into it and use in production. Second is it should be economical, right? It should not be that it runs on some proprietary hardware and it is very expensive. No. So it should be able to run on any kind of hardware. Another thing is it should be easily scalable, right? Tomorrow if you run out of resources, you should be easily able to add more resources without any downtime, without shutting down your cluster or without affecting your existing infrastructure. And it should be flexible. Flexible means I can have heterogeneous environment. I can run different modules. I can run MapReduce. I can run MPI and other stacks on top of the same hardware, right? It should be flexible enough for me. Some of the Hadoop users, although currently there are many, right? But the major ones, Facebook, Yahoo, Google, and banks have also started investing heavily into the big data domain, especially into Hadoop. Why? Because fraud detection, customer targeting, right? The credit rating, a lot of systems have moved on to the Hadoop platform because you have huge data set and you need to quickly, let's say, do a fraud detection. You have to quickly analyze your data or do a credit building for a customer. But the major ones here has been Google, right? So the Hadoop actually came out from a paper which came around 2006 from Google. So Google presented two papers. One was on Google file system, another was on MapReduce, right? So using that paper, Doug Cutting modified the original project, which was Nutch, right? It is also under Apache, and Hadoop came into picture. So there has been a lot of intermediate phases, so which we will not go through in the webinar. And another company is Yahoo. So Yahoo is contributing heavily into Hadoop. So the Apache Hadoop which you see is mainly a contribution by Yahoo. So after that, a lot of people have come into once the project went under the Apache Software Foundation license. So there are now a lot of contributors who are contributing to the Apache or to the Hadoop source base, right? So there are a lot of companies. So you have LinkedIn, Rackspace, Amazon, eBay, right? A lot of companies. These are major big players. But nowadays you have a lot of smaller companies. Let's say Yardley, Quebec, right? A lot of companies are coming into this space. So the job market, right? Over the last few years, especially mid 2013, the market has gone up tremendously for Hadoop professionals. So there is a high demand in the market for people who are into the Hadoop world. there is always a company, right, who is looking to innovate. So when they are looking for innovation, they are trying out Hadoop platforms, right, big data, because they already have a lot of data, so they are trying to move that existing data, which might be stale, right, sitting somewhere on warehouse, and trying to make it live. So they need people who can do that. So the current market trend is the best way to move into Hadoop is, so in the market you find very few people who are actually well equipped with Hadoop skills. So the market trend will be, let's say you are already a system admin from a Linux background, you have a good hold of Linux or system admin skills, so you can groom up to be a Hadoop administrator. So many people within the organization, they move towards Hadoop teams, or the companies, they hire people who are from a system admin background. They have a knowledge about Hadoop, but they might have not worked into Hadoop directly, right? End of the day, it's all about knowledge. So the main skills required for being a Hadoop admin. First of all, very important, as similar to as being a system admin, you should have good troubleshooting skills. Right? You should have good troubleshooting skills. You should understand capacity planning. Right? You should understand, like, let's say if I'm putting one system, how much load it can take, what will be the CPU cycles it can have, how much I/O it can do, what can be the network bandwidth I can have, right? So capacity has a lot of things, right? How much parallel threads I can run, what is the memory it can use, or for example in the case of JVM, how I can tune my JVM to be optimal, right? So these are the core skills you need, like troubleshooting, something goes wrong, how quickly you can find where the root cause of the problem is. So when we say Hadoop framework, there are a lot of things which come into picture. Hadoop originally started with a processing logic or a programming model, which we called MapReduce, and a file system layer which is called HDFS, which is Hadoop Distributed File System. But in addition to that, you have a database, let's say it might be HBase, or you might be running MongoDB. You need a warehouse, let's say Hive. You need some scripting language, which is kind of a data flow language, Pig, which is called Pig Latin. You may need some machine learning libraries, for example, Mahout. So currently you have a lot of libraries, right? Let's say libraries for linear algebra, libraries for doing complex mathematical computations, or a lot of algorithms for, let's say, for doing weather forecasting. So you do not need to reinvent the wheel. So what you do, you just take a wrapper and make it feasible to work with your Hadoop framework. So Mahout does for you. Mahout is kind of a driver of your elephant. So Mahout is a Hindi word, right? So all the people from India might have heard the word Mahout. So he's the one who is the caretaker of the elephant and drives the elephant. So elephant is here the Hadoop. Hadoop is the elephant. They should be able to deploy the Hadoop cluster, monitor them, and scale critical parts, right? So obviously if you are a Hadoop admin, you should be able to set up your Hadoop cluster. You should be able to monitor them for health, monitor them for capacity, monitor them for load, either by using, let's say, Nagios, Gangelia, Genos, right? A lot of monitoring tools are there. And you should also be able to scale them as the need comes. You should have a good knowledge of Linux. So I'm not saying that it is a hardcore rule. There have been people who have been coming from Windows domain, because now the later platforms of Hadoop 2.0, they are working very well on Windows. But the core platform is Linux. Companies, they prefer Linux, either CentOS or RHEL. RHEL platform, which is Red Hat Enterprise Edition, or Ubuntu. Right? Many companies they are also using Ubuntu. So you should have a familiarity with open source configuration management systems like, let's say, Puppet, Chef, Salt, Ansible. So these are systems which are used for auto configuration, because when we are setting up a Hadoop cluster of, let's say, 1000 nodes, I do not want that I should do task manually. It should not be that I go to 1000 of the systems one by one or through some bash script or something and do some package deployment, right? It should be done in a nice, clean way, which also audits it, keeps a track of what packages went where. So you need some centralized system. So for example, like Puppet, right? If somebody is really interested in understanding what Puppet is, they can refer to Puppet Labs. So a really very good tool. And being a Hadoop admin, you do not need to know Java, right? You don't need to be a Java programmer, but it is always good to know how to fine-tune Java. For example, it should not be that you give JVM very less memory or too much memory that it runs out of memory. OOM, right? We call that out of memory kill operation, we call that, right? So it should not be that it runs out of memory. So you should have very core troubleshooting skills of Java, right? Very basic ones, like what is the maximum memory, how you define your maximum memory for a Java process, how you define the minimum memory, how a JVM forking happens, right? How the memory heap, Java heap works, right? All those kind of things. So in a typical Hadoop admin role, right, your day-to-day activities or responsibilities could be like something like implementation and administration of your Hadoop infrastructure, right? So where you might be looking into how you implement and administrate your cluster for looking out for any errors, any alerts. Another could be, let's say you might be testing HDFS, like file system, for its performance, right? Read performance, write performance, or any bad blocks, right? You can be testing out Hive Pick, right? You might be testing whether, okay, a particular application which a business unit is asking for is compatible with Pig or Hive or not. Can we allow them to run on our cluster or not, right? So another task a typical admin does, whether it's a system admin or a Hadoop admin, is backup, recovery, upgrade, and patching, right? So when you're a Hadoop admin, you have to take care of patching the operating system, upgrading the operating system, right till upgrading your Hadoop stack. How you upgrade your Hadoop from one version to another version. So all this have to be taken care by the Hadoop admin. Another thing, very important thing and a very complex thing, performance tuning, right? Because performance tuning, you do not have a set rule. You cannot say, okay, I will put this parameter and my system will run optimal. There are a lot of things which goes into it, right? How much memory you have, what is the hardware you are running it, what is your job load, what will be the job load during different times in the day. Accordingly, you will have to plan your capacity and performance, right? So these are also very important and very challenging tasks. And end of the day, as I was telling you, you have to monitor your cluster using Nagios, Gangilia, or any of your handcrafted tools. And the last thing, but the very important thing currently in the market is Hadoop security. Because let's say when a financial domain, let's say a bank or a stock exchange, moves on to Hadoop platform, security is of prime importance. It's paramount. You cannot have a Hadoop cluster where you store your financial data and some user goes, right? Because let's say I'm in an organization who is running a, let's say, 1000 node cluster. So I cannot say 1000 node cluster I will use only for one app, right? I have to make an optimal use of 1000 nodes. So what I will do, I might have a financial data, I may have a marketing data, I may have a or R&D data, all sitting on the same cluster. But how will I do isolation? How I will implement security, right? This is also a responsibility of the Hadoop admin. How you will partition the data, right? Partition the data in terms of security. So currently, right, so when the Hadoop started, the original Hadoop, we called it as Hadoop 1.0. So 1.0 here means the MapReduce framework 1.0. And the new framework currently which we are using in the market now is Hadoop 2.0. Still many companies are yet still on Hadoop 1.0, but many companies have moved on to Hadoop 2.0 as well. So what is the main difference? In Hadoop 1.0, if you look into that closely, like the framework looks same, right? You will have Hive, you will have Pig, you will have HDFS layer, you will have your MapReduce layer. Uzi is kind of a cron job, right? For the time being, you can think Uzi is kind of similar to a cron job, which is used for scheduling jobs onto your Hadoop cluster, right? It's a coordinator, but it is much more powerful than a cron job, right? There are a lot of things it can do. But the major difference which has come in two frameworks is the introduction of a new layer which is called YARN, which is YARN stands for yet another resource negotiator. So what it does, it takes out all the intricacies or the fine granular details which an admin has to take, right? So when you, let's say, get into a Hadoop admin role or get to go through the details, you will realize that it eases out the work of a Hadoop admin, because now in YARN framework you do not have to worry about what your system has, like how much memory a data node has or how much memory a particular instance need, right? Everything is taken care by the YARN framework. In this Hadoop, right? So when we say we use Hadoop, so it does not mean that in a company when you are using Hadoop, you will not use Oracle or MySQL, right? They will still be there. But how you will integrate them, that is again a challenge, right? That comes under designing and planning. So you have tools like Scoop and Flume, which deal with structured, unstructured, and semi-structured data, right? Let's say I can upload a data from my Oracle into HDFS and export it back to Oracle or MySQL, right? I can do all my processing extraction on Hadoop and load it into a traditional RDBMS. So the core components, right? So the core, when we say Hadoop, up till now we have looked more of a very high level view of Hadoop. So when we say Hadoop, right, there are two important components. One is the storage, means one is the file system. Another is the programming model, which is the processing, which is the brain. So when we say HDFS, which is Hadoop Distributed File System, this file system is distributed across the nodes. Unlike your traditional file system, let's say on a Linux machine or a Windows machine, when you create a file system, let's say you create a NTFS on Windows or ext3 or ext4 on a Linux system. So that file system is created per partition, right? Or let's say if you are given the entire hard drive, per hard drive, so it is isolated within a system. But HDFS is distributed. It is laid across all your nodes. So let's say if I'm setting up a cluster with 10 nodes, so the HDFS file system will be distributed across 10 nodes. So it will not be isolated to one node or one hard drive, right? It can span across. Another important thing is it is natively redundant. By default, replication is 3. What does it mean? If I copy a file, it will be copied to 3 locations automatically. Means 3 different data nodes, right? And another one important difference is here you have a master node which keeps a track of all your blocks, all your metadata. For example, in ext3 what is happening, your file allocation table, right, or the inode structure sits on the same drive where your data is. But in the Hadoop world, it is not the case, right? They sit separately. So there are a lot of details. Okay, we cannot go in all the details in this webinar, but you can take this into mind that metadata sits into a separate node in the case of a Hadoop, and your actual data sits on separate nodes. And MapReduce means the brain or the processing. It splits a task across processors. Means, let's say I have a CPU with 2 cores, so it will split the task. And here, important thing here is, let's say in Oracle MySQL, what we are doing, whenever I run a query, data is pulled in from my DB. Let's say I might be calling my application API from a web server, which is running some query on Oracle DB at the backend. So the Oracle database will be pulled to the app for answering my queries or answering any use case. But in the case of Hadoop, you cannot do that because here data is very large. I cannot move 1 petabyte of data to a node where my app is running. So instead of that, what I can do, I can move my processing to where the data is, right? So this is how it differs from the traditional model. Here we are moving the program code or the processing to where my data is. So this is called locality of reference, near the data. So it has self-healing and bandwidth management feature into it. So if you submit a job, it fails, it is automatically rescheduled by the framework, right? So it takes care of a lot of things, right? So when you are running a very large cluster in production, running a lot of jobs, it automatically hides a lot of things from the admin. It automatically reschedules, take care of failures, right? All those things. So you have a job tracker, right? Which is a master. Job tracker, for the time being, you can think from the name, which tracks the jobs, right? So this is what it is doing. So in the case of Hadoop 2.0, right? This is 1.0. In 2.0, everything remains same, but you have a new feature which is added, which is called high availability in the HDFS. What does it mean? If one master node goes down, master node is the node which was having your metadata, right? If that node goes down, your entire cluster goes out. But in high availability, what a feature it provides you with one more node, so that if one node is out, the second node comes into picture and it takes care of serving the request. And you have a yarn is also known as MapR version 2 or next gen MapReduce. So here it fine-tunes your running of jobs, right? It has taken out a lot of the limitations which initially we had in MapReduce framework, like the number of jobs which you can run, how the scheduling happens, right? How the failure is handled, right? All this have been improved into the new framework. So it is now taking care of the resources in a cluster-wide manner rather than targeting nodes one by one. So let's quickly take a glimpse into a NameNode and data node. Although they are very vast topics, but we will quickly look into that. So as I was telling you, that metadata will be stored in a separate node, right? Metadata means, let's say I have a file 1, who is the owner, what are the permissions, what are the blocks mapped to a file, right? In inode structure on an ext3, we have structure like that, right? So, but in Hadoop, what is happening? Your entire metadata is sitting on a node which we called as NameNode. So the master node here is called NameNode. It is the master of your system. It maintains and manages the blocks. Means the actual data will not be there, but it will know where the blocks of a file are, right? So let's say if you ask the NameNode where file1.txt is, it will say, okay, go to data node 1, data node 2 and data node 3, there your file blocks are. So data nodes are slave, which will actually hold your data. These are the nodes which are responsible for serving your read and write request. So the very first time your master will be contacted to know where the location of your blocks are or know where your data is. But once that is known, you directly go to the data nodes and read or write your data. So when I say metadata, right, metadata means, okay, I have few questions here. So Aryadeep is asking how much Linux we should know to go into Hadoop admin. I am a non-Linux person. Okay, so he's asking, do you provide any prerequisite Linux course for Hadoop admin? Okay, so when we say for the Hadoop admin you need Linux admin skills, so first of all you should be at least knowing the basic Linux. What does it mean? Let's say if you are coming from a Windows domain, you might have not worked on the command line, right? You might have never used, let's say, dir, cd command, how to find a file from command line, because mostly you go to the Windows interface and you search there and you browse through, let's say, double click on C drive, then double click on a browser or double click on a folder and all, right? So in Linux world, you should be knowing how to navigate your system, how to navigate your file system, how to find a file. So in our course, what we do, we have some introductory documents which will help you in building your basic Linux skills. For example, what is ls command, what is a file system, what is the root of a file system, like those kind of things. But we do not provide extensive Linux course, right? So we help you out with, let's say, a few videos which refer to, let's say, many of the students who come to our batch, they might not be Linux guys. So we refer them to some basic Linux videos. You have a lot of good material, let's say, on YouTube. So you can refer them, watch them, which will help you build your Linux skills. Okay, another question from Sandeep is, what is the difference between a Hadoop developer and a Hadoop administrator? Okay, so developer is the guy who is writing actually the MapReduce code, right? Let's say in an organization, you are given a project where you have to do a cookie extraction. Let's say browser cookies, you have to extract them. So what the developer will do, he will write a Java code. What that Java code will do, it will have a string tokenizer, for example. It will extract for, okay, any delimited field by, let's say, a tab, right? It will look for, let's say, the cookie ID, browser ID, the IP, right? Session ID. It will extract it. So this will be done by the developer. Developer is the guy who will be writing your jar files, the MapReduce code. So the Hadoop admin is the guy who will be taking care of your infrastructure. He will be setting up your cluster, maintaining your cluster, tuning your cluster, making sure your MapReduce runs in the optimal way. Another question from Ravi is, whatever operations configurations in 2.x can be done in one except yarn, even we can do HA in one but in a different way. Okay, then why we need 2 instead of 1? Okay, so the question from Ravi is, he's saying in 1.0 also we can do high availability in another way, then why do we need 2.0? Okay, see, although we can do high availability, but that high availability we have to go to the OS layer. Let's say I can do high availability at the Linux layer, highly available Linux cluster. On top of that I can run my Hadoop, right? But in that case, what will be the disadvantage? How I will take care of high availability between the metadata? Because you will have operations sitting in your memory, how your metadata will be shifting over from one node to another, right? Some people do high availability by, let's say, putting more number of nodes behind a, let's say, kind of a load balancer kind of thing. That will be more of a load balancing setup, not exactly a high availability setup. So when we move to Hadoop 2.0, what is happening? The switchover time is minimal. It is almost negligible because your metadata will be live in both the nodes and your data nodes will be talking to both the machines. So if first node goes out, the second one will immediately take care. So here the cluster is or the high availability is directly at the Hadoop component, not at the OS component. Okay, so Sandeep is saying that he has more than 5 years experience in Linux admin, so but he does not have any programming knowledge. So for a Hadoop admin, you do not need programming knowledge, right? It is a totally kind of a hands-on Hadoop admin skills which are similar to your Linux admin skills. Like in a Linux admin, what you do, how you install your OS, how you configure, how you set up your users, how you set up your quotas, how you set up your partitions, right? All those things also come into a Linux. All this also comes into a Hadoop admin course. Another question from Sandeep is, what is NoSQL? Okay, NoSQL stands for not only SQL. So it is based on, nowadays we have a lot of use cases. For example, you may have a document data, right? You may have a data which is not structured, right? So you need a database which can address that. So NoSQL data is more of a based on the column family approach, right? So we also talk about HBase in our course. So NoSQL for the time being you can think of it is a database for addressing large data set which does not need to be in a structured way. Means you do not need a primary key or a foreign key relationship to address or query your data. Okay, I have a question from Philip. How data analysis is done? Are there any tool available to do that? And does managing those tools comes under a Hadoop admin responsibility or another tool? See, the management of tools comes under the responsibility of Hadoop admin. But let's say writing a data analysis algorithm will be someone else's responsibility. Let's say there will be a data analytics team who will be writing an algorithm to extract the data. But how you integrate that tool with your Hadoop admin, Hadoop admin framework will be responsibility of a Hadoop admin guy, right? So many companies will be writing their own analytic or a extraction tool, right? Okay, I have. Okay, Sandeep, NoSQL. Sandeep is asking what is the difference between NoSQL and Hadoop. NoSQL is a database. Hadoop is a framework which has file system, MapReduce, and lot of things you can plug in, right? I can plug in, let's say, Hive, I can plug in HBase, I can plug in MongoDB, right? These are all plugins which I can plug into the framework. Okay, so Swapna is asking, in addition to high availability, what are the additional features we have in 2.0? So we have new features like federation, right? Federation means, okay, if you go into the details of NameNode, there's a limitation on how big your cluster can be. So I can say, let's say 4,000 node I can have in a cluster. So why only 4,000 node? Because the limiting factor is the size of memory on my NameNode. Because I cannot hold more metadata than that in the memory of my NameNode. So federation comes into picture, with which I can scale my cluster into much bigger sizes. So NameNode metadata, for example, I will come to the few questions which are left in a minute, right? Let's go to a few of the slides and I will come back to that, because the few questions which people are asking, they are answered in this slide. So when we say metadata will be like kind of what permissions a file has, who is the owner, what is the block mapping to a file, right? All those will be stored in a memory, right? Metadata, right? Also it will have kind of a transaction log. Transaction logs mean a kind of a bin log of a MySQL, where whenever you do a change, it will be written into a journal and then it will be committed into your file system. We also have a very special kind of a node which we called it as a secondary name node. So secondary name node, what it is doing, it is actually doing checkpointing for you. So what is checkpointing? So in, let's say in a database world, what happens, you write entries to a journal, then the journal is flushed into your actual database, right? Journal is committed to your actual file system. So that process in the Hadoop world is called as checkpointing, right? It is not exactly same, but it is similar. So checkpointing is done by a separate node, which is called a secondary name node. So this is a separate machine, or you can put it on the same machine where your name node is running. So what it will do, it will take the diff or whatever the new writes have been done to your file system and commit it to your HDFS, right? So it's a configurable parameter, how often you want that to happen. So this is what summary is. In 2.0 new feature is, it is actually providing you high availability. It is providing you the scalability, how easily you can scale your cluster, and you can set up your larger clusters because a federation has come into picture. And another feature it provides is you do not only need to run MapReduce. In Hadoop 1.0 you only run MapReduce. But in 2.0 Yarn framework you can run another frameworks. You can run parallel computing also on that same hardware. Right? So this is what I was explaining you in federation. So initially in 1.0 I will have only one single name node and I will have n number of data nodes. But in federation what I can have n number of name nodes as well. But I can have, let's say, 1,000 data nodes or let's say 10,000 data nodes. All are storage units. All can talk to name nodes. Right? Now I will have federation. I can span my clusters much bigger. Right? So this is federation. So there's also a lot of detail. Right? It is not possible to cover all the details in a webinar because it will be better for me to show you few demos rather than going through the slides. So high availability, what does it? Okay, somebody was asking what is the difference between high availability in 2.0 and Linux layer. So if you look at this slide, you will configure two machines running NameNode daemon. Let's say both are running Red Hat Enterprise Edition. So high availability will be at the NameNode layer. So data nodes will be talking to both. So if this node goes down, data nodes start talking here to the other one. Right? So you do not need to take care of high availability at the operating system layer where you have to put, let's say, a Lucy framework, right, in the RHEL, which take care of your cluster suite and all, right, which involves extra cost and extra complexity at the operating system layer. Here you simply put your operating system, reliable hardware, put high availability at the component layer. Right? So you can do that. So in your 2.0, the secondary has gone out. You do not need to configure it. The standby name node does it for you, right? It does the checkpointing for you, which is merging of your delta, right? Merging of your whatever changes you do. Okay, so this is what high availability is explaining you in the Yarn framework also, right? So in Yarn framework, what is actually the main advantage which has come in addition to HDFS is there is delegation done in terms of jobs you submit. The load has gone down on your job tracker, right? Although we do not have job tracker in secondary, it is called resource manager in your secondary, in your new framework in Hadoop 2.0. It is called resource manager. So it is a new framework which has a better resource management, right? It can better understand what memory each system has and it can better answer the questions. So in a typical use case, NameNode will be the one which will be running at higher memory, which will having multiple CPU cores, multiple NIC cards or LAN cards for failover, redundant power supply, so that if one power supply fails, other can take over, and all your framework will be running on 64-bit systems. Why? Because 32-bit system has a limitation of 4 gig memory, right? So here you need more memories. So you will have multiple cores, lot of things, right, will come into picture. So here we will also understand why we need distribution, because it is always better. Like I may have a choice of having, let's say, one single disk of 12 terabyte. Instead of this, it will be better for me to use 6 hard drives of 2 terabyte each instead of using a single hard drive or 12 terabyte. Why? Because it will give me better distribution, it will give me better data density, it will have more number of spindles, more number of heads per spindles, right? All these details we talk about how it affects your performance and all, but this is just a peep into it and overview. So the important configuration files, right, in Hadoop are core file, HDFS file and mapper file. Core file is the file which tells about or which talks about where your master is, NameNode is. HDFS-site file talks about where your HDFS file system will actually reside and where actually it will write your data, right? Where actually the data will be written. Mapper-site will be taking care of your MapReduce part. Means let's say you submit a job, where is the master for that? Where that job will run, right? That configuration goes into mapper-site. In a new framework yarn, which is 2.x, all files remain same, but a new file which has come into picture, which is yarn-site, right? New framework has come into picture, so which defines where your yarn will be running. Okay, Ashwini is asking, can you please share these slides? Okay, I think that could be done by the Hadoop admin team. So I think they will be able to do that for you. Okay, so we have a concept of rack awareness also. So what is rack awareness? So our NameNode is intelligent enough to make a decision. So let's say I'm saying in the previous slides we saw that Hadoop is natively redundant. So what does it mean when I say natively redundant? Let's say I copy a file and NameNode makes 3 copies of it. So it does not mean that it will make 3 copies of that on the same server or any server within the same rack, right? So rack is, let's say, you can think it of as a simple almirah, right? In which you can put your servers. If you have ever been to a data center, you will see it will be a physical rack, a metal casing in which you stack your servers. So your NameNode will be intelligent enough to understand that I should not make replicas within the server sitting in same rack, so that if one rack fails, I will have data loss. So I should put one here and others some other places, so that I at least have one copy somewhere in another rack, so that if one goes down, the entire rack goes down, I can still have my data. So there's a rack awareness algorithm which goes into place. So we are short on time, but there are a lot of detail which goes into the backend how our rack awareness algorithm works. Okay, also your Hadoop cluster can run into various modes. For example, you can have a single machine, you can have a 10 node cluster, you can have a 100 node cluster, you can run, let's say, a name node, a data node, your job tracker, secondary, everything on a single machine, or you can run them in a distributed mode, right? I can run name node on a separate machine, data nodes on separate machine, job tracker on a separate physical machine, secondary on a separate physical machine, right? This is how it runs in a production, so that it's fully distributed, right? And we can have different kind of setups. So let's see, we have few demos. Let's say Hadoop cluster setup, rack awareness demo, secondary name node demo, okay, commissioning, decommissioning of node. Okay, let's see how many we can do, because we do not have, I think, time to do all the demos, but let me quickly show you quick demo of setting up a cluster. So I'm using a virtualization platform. I use both VMware and VirtualBox. So here, let's say I have a machine. If I do hostname, the hostname is nn1.cluster1.com, right? Which nn1 here means name node. So I have given a name nn1.cluster1.com. So let's say I'm logged in as Hadoop root user. So obviously we will not run our any application with a privileged user. So what I will do, So what I will do, I will create a non-privileged user, right? I will create a non-privileged user. Let's say I create a user add Hadoop ID Hadoop, which is a non-privileged user, right? Non-privileged user means that not a root user, so that if somebody compromises my application, he should not have an root access or a system-wide access. So I created a very simple user. I've given a name Hadoop, right? So ls-l/home/Hadoop, correct? So to save on time, I've already downloaded a tarball, right? Which you can download from, if I do here, I go to Google, and if I do Hadoop download, it will point me to Apache releases, right? It will point me to hadoop.apache.org downloader release, right? I will go here and choose the nearest mirror to me, and I will download a tarball, right? I will download a tarball. So I've downloaded a tarball, for example. So I will untar this tar-x extract z vf, right? Where I want to untar /home/Hadoop. So I'm untarring it in my user Hadoop's home directory. I'm untarring it ls-l/home/Hadoop. So we untarred it by using root. So that's why the permissions are coming as root. So we have to change the ownership recursively to be owned by user Hadoop, so that Hadoop can read write to it. Correct? No. So let's create a directory where we will configure it to write, let's say, some. So I have created a directory ls-l/data/NameNode, a directory which will be configuring for NameNode to write some metadata there, right? So we'll see how. So I do su-hadoop, right? Now I have changed as user Hadoop. ls-l I do here. So this name looks quite long for me. So quickly I will do a symlink for this, right? So all this is system admin stuff. So in course we talk about why we do this and all that details, but just for the sake of simplicity, I have done this. So let me quickly copy the profile. So what we are doing here is, on this system, we need to install Java or give the path where my Java is. So here in bash profile, I'm defining wherever I have installed my Java, right? So normally you need to either use OpenJDK, which comes with your Linux by default, or you have to use minimum JDK 1.6, right? So in course we talk about how you install Java and all, but here we have time constraint. So here what you need before running Hadoop platform, you need to install Java, right? So I'm setting up a path for Java. So I exit, login back. So if I say which Java here, so it will be able to find Java for me. Yes, we can. So Samarpan is asking, can we store NoSQL DB files on HDFS? Yes, we can. So this is what, like when you configure a database, let's say HBase, MongoDB, the HDFS will be used as your storage file system. Okay, so Shri Ram is asking which version is this? Currently we are using 1.2, right? 1.2 means 1.x, right? So if the number starts with 2, it is 2.x, right? So because we are running short on time, so I will quickly give you a demo on, let's say, 1.x, how it works. So I've set up a symlink. So where are all my config files are? Hadoop /id. So it has all the files here. It has a binary file, binary directory, which will have all my commands. Let's say Hadoop command, start, stop, daemon, and all those commands. Other directory I will have is a config directory. Which will have my configurations. If I do a ls-l on my config directory, you will see it has some configuration files. Right? It has some configuration files. So let's start with the configuration. I do cd hadoop config vi hadoop env.sh hadoop environment.sh. So what we will put in this environment.sh, we have to tell where my Java is and where I have installed my Hadoop is. Right? So let me just quickly take this parameter from a config file to save on time. So what I'm telling here is I will make an entry like this. What it is telling me, where my Java is in the Hadoop environment file and where my Hadoop is. Then another thing I will quickly do is I will reduce the memory. So it is saying Hadoop heap size. It is talking about JVM. How much JVM it should take? I'm saying 500 MB, right? By default it takes 1 gig. So I'm reducing that, right? Depending upon how much memory your virtual machine has. But in production this will be running it very large amount. It will be running with 100 gig in your NameNode case. So another directory I will quickly change is, I will change where it will write process ID. Process ID means any process which you run in your NameNode or data node or a Linux machine is assigned a process. So I'm saying where it will write the process ID directory. Okay. Then important file vi core-site. vi core-site. So this is the file which will tell me where my NameNode will be. So this is all files are XML files. So they have an opening and a closing meta tag, right? Let's say opening configuration tag, closing configuration tag, right? So let's quickly copy the contents and I will explain you what each are, right? But we do a thorough walkthrough in our course, right? So I will put parameter like this. So what this parameter means, so all are XML parameters: opening, closing configuration tag, opening, closing property tag, right? I have a name and a value. So we define a property which has a name and a value. So when I say fs.default.name, so it is saying file system default name node, where it is. So I'm saying nn1.cluster1.com, a particular port. If I do not give any port explicitly, it runs on 8020, but I can give my port. So this is my host name. So I'm saying NameNode is running here only. Correct? Now vi HDFS-site. vi HDFS-site. So this is the file which will define where my metadata will be stored on the disk. Where my metadata will be stored on the disk. So I will say something like this. So I will say dfs.name.dir, right? Name.dir. So which directory we created? We created /data/NameNode. So I will say /data/NameNode, right? I will give that here. So this is the directory where NameNode will be actually storing its metadata, right? So if I do ls-l/data/NameNode, you see this directory is empty currently, right? This directory is empty. So the very first thing which we have to do here is Hadoop NameNode format. So the moment I execute this format command, so you see this deprecated message and all. Why it is coming? Because we are using Hadoop _home variable in Hadoop environment, Now it has been replaced with prefix, right? Or I can do a suppress also. So I say yes here. It is asking me to format. So I say format it. So let's see whether it has formatted or not. Okay, so let's look into vi Hadoop config HDFS -site. Data name node, okay. Okay, we have to change the permission. Right, so I have to change the permission because that directory should also be owned by user Hadoop. So I'm changing the directory permission because this permission is coming as like this here. I go back, I execute the format command again. I say yes. Right, so now ls-l/data/name node, you see it has formatted it. Right, so this fs image is the file which is the metadata file system image. Edits is the file which is your journal. Means whatever changes you do to your Hadoop file system will be written here, and this will be merged during checkpointing. Version file will be the file which will store your cluster ID, right? So there are a lot of details, right? In this, we do not have the time to go in all details, but what this version file is telling you, it is telling you a cluster ID, namespace ID. So this will be randomly generated ID. So this is the ID which will remain unique throughout your cluster, and it should be same. What does it mean? I should never execute this format command again. Once I have executed the format command and my cluster is up, if I execute this command again, my namespace ID will change. So my data nodes will not be able to communicate with it. Okay, so we will execute only once, right? So there are a lot of details which goes in this. So once I have done that, so we will do Hadoop-daemon.sh start name node. I will start my name node. I do JPS. So I see my name node is up, right? My name node has come up. Now same thing, let's go to data node. Hostname dn1.cluster1.com, which will be configuring as, right? We will be configuring as a data node dn1.cluster1.com. So same thing, ls-l. So here I've already have data nodes ready, means with the config file, but let me show you what difference it will have. Core file will be same. Data nodes should also know where my name node is, right? So they are pointing to where name node is. But what will differ here? The HDFS-site. So HDFS-site, what it will be? HDFS-site, here it will say dfs.data.dir, right? So here, okay, let me reduce this, remove this for simplicity. Here we can give comma separated field because data node can have more than one disk. So we can give comma separated field of all my disks. But let's say here I'm giving only one. Right, here I'm defining replication. By default replication is 3, but if I want to change, I can explicitly say the replication. So I'm saying their data node will store here. So here it is dfs.data.dir. On name node it was cat Hadoop config HDFS. Here it is dfs.name.dir. So this is the only different parameter. I stop it. So ls-l / space disk 1, you see it is empty. So the moment I start my data node, start data node, it will go and talk to NameNode. How it will know where NameNode is? From core-site. So the moment it contacts NameNode, NameNode will see that this is a new file, new data node. Why? Because this data node does not have any cluster ID. Because this data node was not part of any node or part of any cluster. So the moment I start it, it will go talk to NameNode and it will ask, can I join you? So NameNode will say, okay, do you have any cluster namespace ID? Data node will say, no, I do not have. So it will pass its own namespace ID back to the data node. So now here we saw this was empty. The moment I started it, you will start seeing it starts writing a lot of directories here. Right? Each directory has a meaning, but let me show you quickly this version file. So this version file will be having a number which will be coming from NameNode. See? So this is the number which is identifying what all nodes are part of a cluster. Right? So let's say my cluster is up and I started writing data, and after that I go to NameNode and do a format command. So format command is done only on the NameNode. So this number will change. So this data node will no longer be able to join the same cluster. Right? NameNode will not let it join. So if data node comes with this name ID and tries to join a NameNode with a different number, NameNode will fire a shutdown command on the data node so as to avoid any corruption of data. So here if I do Hadoop DFS hyphen DFS admin hyphen report, right? So it is showing me that I have one data node. Okay, so this is only a warning. If I change it to prefix, it will go, or I can say export Hadoop underscore home underscore supre suppress underscore 1 is equal to true. Okay, I think parameter is 1 underscore suppress suppresses at the end. Okay, see that warning started going. That warning is not coming right now, right? Initially this warning was coming, right? So we can suppress the warnings. So let me just quickly show the other two nodes also, and I will quickly show you a demo on rack awareness also. We might not be able to do, let's say, secondary and all. So there's another machine, hostname dn2, hostname dn3, right? / space / disk 1. Okay, I'm emptying the data or any data it might have there, right? So this data node will also have Hadoop config core-site, which will say where my name node is, HDFS-site, which will tell where it should store data. So I say Hadoop-daemon .sh start data node. So currently we are starting components one by one, but there is another way of starting everything in one go, right? Which we also see in our class by setting passphrase less access. Okay, second data node is up, third data node is up. So now I go here and let me execute the command again. Right, so now it is showing two data nodes. Third one is coming up. It will, after some time, you will start seeing one more entry coming here. It will start seeing three data nodes. Okay, so now let me quickly show you rack awareness also here. Okay, see now it started saying 3 data nodes. What all 3 data nodes? I can see this from the graphical interface also. I give the IP of my name node and I give a port, which is a web port, right? I can see the same interface. It will say, it is saying me 3 live nodes. I click on this, it is showing me 3 data nodes I have, right? So currently all 3 data nodes by default, they will be in the default rack. There's no mention of rack anywhere. If you see, there's no mention of rack anywhere. So let me quickly show you a copy of file, vi test, let's say a file. This is test file, right? So let's copy this file, Hadoop fs-put test onto HDFS, right? So these two are different. This is my local file system, and Hadoop fs-ls, this is my Hadoop file system, right? Anything preceding by Hadoop. So I can say cat test, correct? So if I do Hadoop fsck on test hyphen files, right? All these has a meaning which we talk in detail, but let me show you the command. Locations hyphen racks, right? For example, I want to see where a particular file is. See, currently it is saying that this file, because it is replicated 3 times, replication is 3 by default, so it went to all 3 data nodes. See, 3 different IPs, but all in default rack, because we have not configured rack awareness, right? So let me quickly show you how you configure rack awareness. So we go to the name node, which is this name node. I open vi Hadoop config core hyphen site file, and here I will enter a parameter which will talk about a script file which will tell it where my rack awareness script is. So I'm saying I'm entering a parameter topology.script.file.name. I'm saying to name node that there's a script file at this location, go and execute it and read it, which will tell you how the data nodes are, right? So let me quickly create a topology.sh. So it is your wish. So I've written this in bash. You can write in any scripting language, bash, Perl, Python, whatever you are comfortable with. So this script is very simple. What this script is doing, it is reading a file line by line and echoing it out. What does it mean? I will create one more file, topology.data. In that I will write 192.168.1.72, which is my data node IP, /rack1. I will say 192.168.1.73/rack2. 192.168.1.74/rack2, right? So I'm saying there are 3 data nodes, 1 in 1 rack and 2 in another 2 rack, right? So I can give the host name also or IP also. Here we are creating this manually, but you can populate this through from DNS. Okay, so let me make this topology.script executable. Okay, so now if I execute this script without giving any parameter, it does not give me any value. But if I enter a value to this, it echoes whatever was written in that file in the second line, right? If I give a number which is not there in the file, it will say /default. So this is what my script is doing. It's a simple bash script. If reading file one by one, so if it finds that argument in the file, it echoes the second element of the array, else it will echo /default. Correct? So now let me quickly restart my NameNode. Sorry, spelling is wrong. NameNode. I'm stopping NameNode. Whenever you make any change to the parameter, you have to stop the daemon. I'm starting it back. Right. So now let's execute the Hadoop report command again. See, now you started seeing rack coming here. Now NameNode knows where each data node is. Right? So when we say that NameNode is aware, rack aware, so it does not mean that it will go and scan the topology. It will just look into that file. So it is the responsibility of the Hadoop admin to make sure you make right entries in the file, right? So if, for example, if in this file I made a wrong entry, instead of even if this data node existed in rack 3, but by mistake I said rack 2, NameNode will take it as rack 2, right? So it does not know. So it will take whatever I say in the file. So now, see, it has done this. Rack 1, rack 2, rack 3. Now if I again copy a file, let's say vi test, okay, let's create a new file, vi new, this is new, right? I copy this file again, Hadoop fs-put new to HDFS file system, right? And I execute this again, the topology script command, the long command which we executed on the file new, right? So now here you will start seeing it. Now it starts talking in terms of rack. So now it's saying 2 copies it has made on rack 2, 1 copy went to rack 1, because by default replication is 3. Right? So we talk about all these things in details. So it might not be possible for us to cover secondary here because we are already short on time. So similarly, there's a concept called commissioning, decommissioning a node. So what does it mean? Let's say I have 3 data nodes here, right? Data node 1, data node 2, data node 3, right? So if I want, let's say data node 3, tomorrow data node 3 having some faulty hardware, and I want to remove it from my cluster. So one thing is I go and stop my data node daemon, but that will take a very long time because NameNode will not mark a machine dead till 10 minutes because each data node is sending a heartbeat. So it waits about approximately 10 minutes for a data node daemon not to send a heartbeat, then only it marks it dead and then it starts copying, right? But I want, let's say, data node 3 to be decommissioned. Right. So quickly let me show you how we will decommission also. Okay, let me just show you one more parameter here. So we go to again NameNode, vi Hadoop -config HDFS -site. Right. So I will copy a parameter which will be dfs.host.exclude, and I will give a name of a file. That file might be empty, doesn't matter. I'm giving a touch excludes, right? And I quickly restart my NameNode. So whenever you make a change to a parameter, you have to restart the daemon. So that's why in production what we do, we make entries of all the parameters in advance, whether we need it or not. So here exclude file is empty, right? Excluded file is empty. Hadoop DFS admin -report, if I do, you will see all 3 data nodes are up and live and NameNode can see them, and my exclude file is empty. So let's say I want to remove a system. I will make that entry here. I have given the name of that data node here. So I made an entry. So one thing is I can restart my NameNode daemon, stop, but in production this is not the right thing to do. What I can do, instead of doing, I can do Hadoop DFS admin. I do not need to remember commands. There's a command called -refresh nodes But let's say if you do not remember, I will simply hit enter. So it will list me all the commands. So I will say refresh nodes. So what does this command mean? It is telling NameNode to reread its files. Right? So I said refresh nodes. So now let's see. I say report. See, it started saying decommissioning in progress. So decommissioning is a process where it will start moving the blocks which were on that node to some another nodes. Once the copy is done, it will shut down. It will fire a shutdown command to that data node, and that data node will, this daemon will automatically go down. Right? This is how you decommission a node. Okay. So any questions you have? Right? We talk about a lot of details. Here I have mostly given you a kind of an overview or peep into what it is. So I have a question from Hari. He's saying, is this webinar recorded? Okay, I think you can probably drop an email to Hadoop Admin at edureka.in. Right? They will be able to answer you. If it is recorded, they will be able to provide you a link where it is. Right? Hadoop Admin at edureka.in. Right? The email is Hadoop Admin at edureka.in. Right? Feel free to reach out to them with any queries, or support at edureka.in. Right? Drop an email to these IDs. They will be able to help you out with any queries. Okay, I have a question from Abhishek. He's saying that he's a software developer. And what are the possibilities in learning Hadoop? Okay, see, as I was telling you, this question came initially. See, for a Hadoop admin, obviously it's good to have some system admin skills, right? So it does not mean that you need to know hardcore skills. To start your learning, you need to know the basic, like let's say how you navigate through a file system, how you change directory, how you set up a path and all, how you execute a command and all that, right? But as you go along, you have to develop on the Hadoop admin skills to be really good in your job. Prabhu is saying it is amazing how you are able to include so much content. Okay, see, we couldn't go in deep because this is Hadoop is very technical, right? There are a lot of details. I have not talked about what is the HDFS block size, how NameNode, data node they communicate, how it decides what to talk, and what data report it sends, right? I've just given you quickly an overview, right? But in the course flow, right? How our course flow is, this is how our course flow is. Our course is divided into 8 modules. So we have, let's say in module 1, we will be talking about the cluster administration. Then we will go a deep dive, taking each component at a time. Let's say HDFS. We look into the details of the file system, right? We'll set up different type of clusters. We will set up job tracker, secondary, everything. Then we'll talk about high availability, for example, in the new framework. We'll talk about how you plan your cluster. Let's say somebody gives you 10 terabyte of data, right? How you will plan, how many data nodes you will put, what will be the memory you will put on each node, right? How you will arrive on that decision. What will be your retention policy? How you take a backup, recovery, how you do maintenance, right? All those things. You will go to advanced topic, for example, HDFS federation, security, right? Kerberos, how you run Kerberos, right? Configure Kerberos. How you do automatic failover, how you do Hive HBase administration, right? Although Hive and HBase itself, they are dedicated courses in themselves, they are very vast. But being a Hadoop admin, you should know how you will set up HBase, how you will set up Hive, how they talk to each other, right? How you manage them, right? Basic things, right? We should know that. And in the end, we will be talking about a project, right? Project and some other things like say a Cloudera manager, how you set up a Cloudera manager, how you use a graphical tool to set up your cluster. Here everything, let's say we are doing manually, but how you can do by a graphical interface also. Yes, Vinod, we cover Zookeeper in our HBase and automatic failover, right? Okay, so Manoj, for that, Manoj is asking what sorts of courses Edureka has for data analytics person. They are also running a data analytics course, a specific data analytics course, right? So if you need any specific information, let's say about the courses, how the course flow will be or anything, so you are most welcome to reach out to Hadoop Admin, right? You can call out their number, so they will be able to answer your queries, like what courses they run, what course will be more suitable for you. Let's say you are asking me for data analytics. So there's a data analytics course also, so very specific course to analytics only. So Sudeep is asking, will Edureka provide any jobs in Hadoop? See, they will be helping you or building you for a job. Let's say when you go through the course, during the course we will be talking about a lot of scenarios. And a lot of students ask me about, let's say, the job interview questions and all, right? We share those kind of information, right? And also many times after the course, students reach out to us asking, okay, that they have an interview, so can they talk or can they have kind of a preparation or reach out to some instructor with their queries, right? Those things you are most welcome. Okay, sure. So anybody who has any more queries, right? They're most welcome and free to reach out to Hadoop Admin and the support team, and they can call the number also, the support number. Let me show you the number also. Right, so these are all the courses which Edureka teaches. You can pick whatever course you want, but let's say you want to reach out to any number of asking for any specific information, right? So you can reach out these numbers, or you can also drop an email to support, sales, or Hadoop admin as well. They will be able to answer your queries, or you can drop in your queries here, right? Any sort of queries. Okay, Balaji is saying that he's from a mainframe background. So which course will be more suitable for him? He's saying choice between Hadoop admin or a developer. So from a mainframe framework, so if you are a app developer, or if you are an admin, let's say you are taking care of a mainframe, message queues and all that, right? Setting up mainframe and all. So if you are from a Hadoop admin course, from a admin background, so admin course will be more on your timeline. But if you are, let's say, from a developer background, then going with a developer course will be kind of for you on the right track, right? Because for a Hadoop developer course, you need some Java knowledge, right? Some programming basic knowledge, right? You should be knowing about the basic algorithm, the program flows, right? The simple program statements and all. So Manoj is asking, is it necessary for a data analytics person to go through Hadoop admin course? See, if you are asking necessary, no, it is not necessary, but it enhances your knowledge. For example, you might be a data analyst, right? You are writing an analysis algorithm and you are writing a use case. But if you understand the framework which is underlying, where your analysis will be run, so it will give you a better understanding, right? How you will be dividing your data set and all, right? But obviously it is not necessary. Okay guys, so I think that's all. Thank you very much for your time, and I hope this session was informative for you, although we overshot our time, but I hope whatever time we overshot, it was useful for you. And any queries, feel free to reach out. Okay, not a problem. You're most welcome, guys. Have a nice day, and thanks very much for attending this session. Take care, guys. Thank you very much. Bye-bye.